Lesson 6.3 is a little bit interesting in that we call it Untitled Polygons. And what that means is no matter how many sides a shape has, you can figure out how much the angles are inside or how much each angle is. So if I told you that you had a triangle, what do the angles in a triangle add up to be? 180, right? We know that. Okay, so if I gave you a quadrilateral, do you guys remember how much a quadrilateral adds up to be inside? 360, okay? So as we keep adding sides, can you figure out how much is inside the polygon? That's what this lesson is about, okay? So the first thing I want to draw your attention to is this list on the right side in that box, all right? You don't need to memorize this, but you need to be familiar with it. So a 5-sided figure is called a pentagon, 6 is a hexagon, 7 is heptagon, 8 octagon. What's an octagon shape we see every day? A good stop sign. Okay. 9 is a nonagon, and that sounds like 9, right? 9, non. 10 is a decagon. 11 is an undecagon. And then after 12, which is a dodecagon, which, by the way, this would be easy to remember if you know Spanish. Do any of you know Spanish in here? No? Some of you? Okay, because deca means 10. Okay, not necessarily in Spanish, but deca means 10. And then if you have undecagon, oh my gosh, this is driving me nuts. I might just have to write on the board. Okay, the word undecagon, means 1. Like uno, right, in Spanish is 1. So that means 1 plus 10 gives you 11. If you look at dodecagon, dos in Spanish is 2, correct? Okay, so 2 plus the 10 gives you 12. After 12, though, there are no special names. So if something has like 30 sides, we would just call it a 30gon, a 50gon, a 52gon. Okay, it doesn't get special until number 20. Number 20, for whatever reason, has a special name, and that's called icosagon. Please say that with me. Icosagon is 20 sides. Okay, Patrick, put your phone away, please, all the way away. All right, a polygon is a closed figure formed by a finite number of coplanar segments. All that means is it's a shape that has no open sides on it. Okay? So from any one vertex, if all the diagonals are drawn from the same vertex, they create triangles. And I will explain exactly what that means in just a minute. So the number of triangles in any shape, no matter what the shape is always going to be 2 less than the number of sides. So we're going to put that in that blank there. The number of triangles is 2 less than, oh my word. Okay, the number of triangles is 2 less than the number of sides. Two less than the number of sides. We let n always represent the number of sides. Okay? N is always going to be the number of sides. So we're going to make an equation or a formula, n minus 2. So we're going to do 2 examples. The first thing we're going to do, the first one we're going to do is called a pentagon. Okay, so let's talk about a pentagon. You guys know in Washington, D.C., has anybody ever been to Washington, D.C.? Have you guys seen the Pentagon? Okay, it's a 5-sided building, government building. A pentagon has 5 sides. So if it's a pentagon and it has 5 sides, how many triangles is it going to have? 3, right? Because we did 5 minus 2 gives us 3 triangles. That's where it came from. The number of sides minus 2. And it's always going to be minus 2 no matter what. Because if I look in this diagram, if I were to start at this vertex up here at the top and draw as many triangles as I could to the vertices, well, if I draw from here to here, this is already established, and from here to here, that's already established. So how many triangles did I create there? Did someone say 7? 3 triangles, right? 3 triangles are the only number of triangles that can be created in here. So let's look at another shape. If I look at a 7-sided figure called a heptagon, we know it has 7 sides. So 5 triangles in a heptagon. So let's try that. Let's start up here and let's try to draw 5 triangles. Go to each vertex. I can't go to the 2 that are right beside it because those already exist. So we have 1, 2, 3, 4, 5 triangles. And this is going to happen no matter how big the shape is or how small the shape is. Okay, so the number of triangles is going to be really important. Let's talk about this. If I'm in a pentagon and I want to know how much total are the inside of the angles, that's the sum. If I want to know the sum of all the angles on the inside of a pentagon, well, how many triangles do I have in a pentagon? 3. How much are the degrees in a triangle? This is not a trick question. We've done this for 6 weeks. How many are the angles in a triangle? 180. So I have 180 in here, I have 180 in here, and I have 180 in here. So if I were to add all 3 of those triangles together, what is 180 plus 180 plus 180? 540. So we got 540. And we got 540 because we took the number of triangles, multiplied it times 180. So over here on the heptagon, if I had 180, 180, how many times am I multiplying 180 by? 5, right? Because there are 5 triangles. What does that give me? 900? So that means that all the angles in a heptagon are 900 degrees. All of them together. Okay, so that's going to be our next blank. So we just already talked about our next blank. Just waiting on my computer. Technology. All right. So the sum of the measures of all the interior angles in a triangle, okay, is the number of triangles times 180. So how did we figure out how much one triangle was? Or how many triangles there were? What did we do to find out how many triangles there are? N minus 2. Okay, so next to this, I want you to write N minus 2. We figured out how many triangles. Then we multiplied it by 180. So for the pentagon, I found it was 540 because I did 3 times 180 because there were 3 triangles. And over here, I found that it was 900 degrees inside of a heptagon because I did 5 times 180. Okay, well, if I had my pentagon, and I know that it's 540 all inside of here, how could I figure out how much each angle was? How could I know how much this one was, this one was? What could I do with that 540? Divided by what? 5 angles, right? If I know that it's 540 altogether, I could divide it by 5. Okay, so do that. What's 540 divided by 5? 108. So that means each angle inside of a pentagon is 108 degrees. Because I did 540 divided by 5. Back row, why are we not writing down? Do you guys need to stand? Okay, pick up your pencil, please. Okay, so let's figure out how much is in, how much each angle is in a heptagon. So what are you going to do? 900 divided by what? 7, because there are 7 angles. So 900 divided by 7. Are you getting a decimal? Okay, that's okay. It's okay to have decimals with these, because some of them are not going to turn out to be nice and even. Let's round to 1 decimal place. So I have 128 point what? 0.57, so that would give me 128.6. So each angle is 128.6 in a heptagon. Okay? And the way we did this is our general formula. We took our total, and we got our total by doing n minus 2 times 180, right? We took our total of our degrees, and then we divided it by the number of sides, which is n. The things that I'm writing in blue are going to be really important for you as you go to do your homework. These are the general formulas to find any sided figure. Okay, so that's how we find each interior angle. And then something to note, each exterior angle, if we go back to my diagram over here, if I say that this angle is exterior with this orange one inside, what do I know about these two together? What do I know about these two together? They're a linear pair. They make 180, and if I tell you that this is already 108, how could you figure out the other one? 180 minus 108. Okay, so let's do that. What is 180 minus 108? 72. So that means every exterior angle of a pentagon is 72 degrees. And I got that by doing 180 minus 108. 108. Okay, let's do this one over here. I want you to figure out how much is left for an exterior angle of a heptagon. Vanessa, what did you get? 51.4? Does anyone agree with that? 51.4? Here's a little hint. Let's do something. Let's try something out. If each exterior angle is 72 degrees, and how many exterior angles are there for a pentagon? Don't think too hard. What would you guess? There's 5 interior, there have to be what? 5 exterior. Let's take 72 times 5. What is 72 times 5 in your calculator? 360. Okay, interesting. Let's take 51.4. And how many exterior angles are there of a heptagon? 7. So what's 51.4 times 7? 359.8, which is really close to what? 360. Here's the rule. All the exterior angles of any shape, no matter the number of sides, always add up to be 360. So the exterior angles always add up to be 360. So if you want to make yourself a note, all exterior angles add up to 180. Thank you. 360. Just kidding. Thank you for making sure you're paying attention. Okay, so the formula for that is really, you can either do your 180 minus whatever the interior angle is, or you can just take 360 and divide it by n. Because if you do 360 divided by 7, you're going to get 51.4. So your bottom line is what we just stated. is that if you take all the exterior angles, they're always going to add up to be 360 no matter what. So if you did 72 times 5, you would get 360. This is always 360. If you do 51.4 times 7, you get 360 as well. Okay? So all the outside angles always add up to be 360 degrees, no matter the size or shape. So that's what your theorem there at the bottom says. If a polygon is convex, then the sum of the measures of all the exterior angles is always equal to 360. So that's your blank there, is 360. Okay, now they're not just going to ask you to fill in a chart. However, you are just going to fill in your chart for your homework. But on your test, or when would you ever use this in real life? Thank you for asking. Let's look at the back page here. It says find the exact measure of each interior angle of a regular dodecagon. All right, so the first thing that we need to do is figure out, what are they asking me to? We're finding each interior angle. Without looking back, let's think about how we find each interior angle. What's always the first step? To find the what? Number of triangles. So we always have to do n minus 2. Then to get the total inside of the dodecagon, we would multiply the triangles times what? 180. But if I wanted to know how much each one was, once I got that total, I would do what? Divide it by the number of sides, or number of angles. Okay, so just thinking through the process, you don't necessarily have to memorize the formulas. Okay, so how much is a dodecagon? 12. And you can look back, that's fine. So a dodecagon means that our n value is 12. Okay, so now I'm just going to plug it into my formula over here. 12 minus 2 times 180 divided by 12. And now I'm just going to rely on my calculator. Tish, what'd you get? 150. What does that 150 mean? Each interior angle is 150, and that's what I expect you to write. Each interior angle is 150 degrees. Bless you. Okay, part B says name the polygon whose interior angle sum is 2,340. So now they're actually giving you the final answer and you have to work backwards. So we are trying to find interior angle sum. So how do we figure out how much the angles add up to be? What do we have to do first, always? N minus 2. Then what do we do with the number of triangles? Always multiply that by what? 180. Now, if it said the interior angle sum, that means all the angles together. So are we going to split this number once we figure it out? Like, are we supposed to divide by something? Are we splitting it up? No, because it says the sum of all of them. So this is where we're going to stop. We're going to use this formula here. N minus 2 times 180. But they tell me already what it should equal, because I don't know what n is. I don't know how many sides I have. They tell me already in this problem that it should equal 2,340. How do we solve this problem? I would divide by 180. If you want to distribute the 180, you can. You're going to get the same answer, but it's just more work. So let's divide by 180 first. So we're solving this for n. So we get n minus 2. What do you guys get? 13. So that means n is 15. So this means the shape is or the polygon is a what? Does 15 have a special name? Is a 15gon. That's all you're going to write. The polygon is a 15gon. Right, because if I'm solving for n, over here, if I'm solving for n, I have to add 2 to each side, right? And then I get 15. Sorry, I skipped that step. Okay. Letter C is a little bit more confusing, maybe a little bit longer. It says, name the regular polygon. Okay, so now I have to figure out what n is. Name the regular polygon whose measure of each interior angle is 5 times the measure of the exterior angle. Whew. Okay, so let's talk about this. We know that each interior angle has a formula. Okay, so each interior angle we know is represented by what? Each interior angle is n minus 2. You can look back if you need to. Times 180 divided by n. Right? That's that formula. N minus 2 times 180. What does is mean in math? Equals, right? So I have an equal sign right here. So I know I'm going to put equals 5 times the measure of each exterior angle. Bless you. So I'm going to multiply something by 5. 5 times each exterior angle. How did we figure out how much each exterior angle is? What did we have to do? Look back if you need to. Each exterior angle is 360 divided by n. So that's what's going to go over here with the 5. 360 divided by n. Okay, this seems like, this blue thing over here seems like a monster problem. It's really not. All right? I can get rid of my n's because if I multiply this side by n, it cancels. And if I multiply this side by n, it cancels. So I'm left with n minus 2 times 180 equals 5 times 360. I want you to solve this. Don't wait for your classmates to do it. You need to be working it as well. Should get n to be 12. What is a 12-sided figure called? Dodecagon. Dodecagon. Because if we have 12 sides, if our n is 12, then that means I have a dodecagon. Okay, does anyone have any questions on letter C? All right, letter D, it says find what x is. So I could add, I think you guys would agree, I could add 90 plus 115 plus 87 plus 123 plus x, but I don't know what I need to set it equal to. So the first thing I need to do is to figure out how much I need to set it equal to. So I need to know the sum of all the angles inside. What kind of a shape is this? How many sides are there? 5. So this is a pentagon. I need to find out the sum of the interior angles. How do we do that? The sum of the interior angles. Number of triangles times what? 180. How many sides did I say there were? 5. So this is 3 times 180. So all of this adds together to be what, Chris? $540. So inside this pentagon, all 5 of these angles add up to be 540 degrees. So now it's an algebra problem. X plus 87 plus 123. I have a 90-degree angle in there. Plus 115 equals 540. Rule of algebra is to combine like terms first. Question? What did you guys get for x? 125. Perfect. X should be 125. Okay, let me show you quickly what you need to do on your homework for 6.3. I'm going to do an example with you. This is the last thing in chapter 6. So you have this chart. All right, so on this chart, I want you to see that you have been given different things. Okay, you've been given one piece of information about each thing. Now, if you look at this chart, you are talking about columns. So you are going down. You are not going across. You should be going down. All right? So based on what they give you, that's where you have to start. Everyone clear on that? Based on what they give you, that's where you have to start. So if I wanted to start in column 4, okay, I'm going to start in column 4. What was I given? Okay, I was given the sum of the interior angles. So that's where I have to start. And I know that this is the formula for the sum of the interior angles. So off to the side, I'm going to do n minus 2 times 180, you can use a separate sheet of paper, equals 1440. $1440 divided by 180 is what? Go ahead, Amanda, what is it?
8.
8. So I have n minus 2 equals 8. Don't worry about writing this down. I'll leave it up there. I want you just to watch for a minute. So n minus 2 is 8. If I add 2 on each side, I get n to be 10. If my n value is 10, what is this shape called? A decagon. So that's what I'm going to write in the very first column, is decagon. The next column is asking me to find my n value. Well, how much is our n value? What did we just say it was? 10. If I know that it's 10, I can solve the rest of this column. Would you guys agree with that? Because I can just plug 10. Look up here. I can just plug 10 in here for my n, in here for my n, in here for my n, and here for my n, right? I can plug 10 in every single way and fill out the column. That's how this is supposed to work. You have to start with what they gave you. All right. Any questions on this? Do we need to do another one? Okay, let's, I'm trying to find a hard one. Let's do column number 6. Okay, column number 6, they gave you 160. And it's equal to this n minus 2 times 180 over n. Okay, so I have to set that equal to each other, and I have to solve it for n. So let's all do it together. N minus 2 times 180 over n equals 160. Because if I don't know what n is, I'm not going to be able to figure out anything else in this chart. Okay, in this problem, I can't knock out my n's. So I need to get rid of n on the left side, so I'm going to multiply by n. But whatever I do to one side, I have to do to the other side. So I have n minus 2 times 180 equals 160 n. Now, if I were to try to divide by 180, I'm going to get a decimal, right? 160 does not divide by 180. So it doesn't make sense to get rid of 180 first. So what I would do first is I would distribute this 180. So I get 180n minus 360 equals 160n. Okay, because we already have an n on the right side and nothing else is over there, let's take our 180n over there. So let's subtract 180n. I get negative 360 equals negative 20n. What do you get n to be? 18. So that means my side measurements, my number of sides is 18. So what's this called? An 18gon. Okay, so if we filled in the rest of this column, the next box says the number of triangles. How many triangles are in an 18gon? 16. So that's going to go here. The sum of the interior angles means I'm going to do 16 times 180. And you can write that small inside the box. You can show your work inside the box. That's fine. 16 times 180. $2,880. That's a big number, but remember we got 18 sides to deal with, so it should be a big number. Okay, this one's already figured out for us. 160. Each interior or exterior angle means I'm going to do 360 divided by 18. What are we getting? 20. So each exterior angle is 20. You could have also have done the 180 minus 160, remember? And that will also give you 20. And then the last box is how much do all the angles add up to be on the outside? What's your last box always going to be? 360. That doesn't change. Okay, you have front and back to work on. Now, on the back, let's look at the back really quickly. You have a couple boxes that have stars in them. Do you guys see that? There's some asterisks on the back side of this. The ones that have stars means that those are going to be decimal answers. And the asterisk at the bottom says no decimals, keep exact answers. I'm okay with you using decimals like we did in our example. Just give me one decimal place, okay? All right. Any questions on this? Do not get up yet.